So there are basically these are the numbers, the degrees one when this sprinkler operates. Okay, so orange is 57 degree, red is 68 degree, and 79 is yellow, and 93 is green, and 141 is the blue. Okay, so basically how the sprinkler works, there is a fluid inside this bulb, and this is already filled with unpressurized water, and then when the fire occurs, what happens, this plate collects the heat and that transfer to this bulb. The property of this fluid inside this bulb is that when it gets the heat, it starts expanding, so when the expansion happens, what happens, it breaks this glass, and once the glass is broken, then this valve it comes out, this is holding inside only because of this bulb. So once the bulb breaks, then this comes out, and then it starts spraying the water. Okay, so this is like a physical, very simplest explanation of the sprinkler, how it works. And the minimum requirement of the pressure is 1 bar in the remotest location of the sprinkler. The farmost sprinkler have to have 1 bar pressure at least. Okay, so this is that one, right? This sprinkler, now based on the application, we use the different kind of temperature systems. So for high hazards, we use these ones, the high temperature ones, and then the low temperatures we use in the our, like normally we use this 60, 68 and 79. Okay, so I'll tell you, this one, the 67, we normally don't use it. Okay, in very light conditions, the application is there, but normally we use the 68 and 79. Okay, so in the, what conditions, so suppose if the room is air condition space is there, then we will use the 68, and if the air condition space is not there, then you will use the 79. 1 minute, who's coming back and forth? Where is it going? Who is requesting? Okay, so this you no need to remember, but you just understand, this is important when you are taking the BOQ. That's why I'm explaining. Technically, as a BIM coordinator, you don't have to worry about these all color codings and all, and the operation, temperature operation. But the thing is, sometimes the BOQ, your engineers ask you, can you give me the quantity of the sprinkler to order? So in that case, you need to know that what kind of a sprinkler you are using in which area. Like based on that one only, you can give the quantity to them, so that they can order the perfect quantity. Like, so you cannot, once you'll give the quantity, he'll ask you that what kind of sprinkler you are using. Okay, so in that 68, 79 and 57 we are using. If it's high hazard class, basically we are not doing that kind of project mostly. So if you are using, then you have to study further, about these things. But suppose this one you are using, so if the area is conditioned, like air conditioned, then you will go 79, sorry, 68, and if not conditioned, then you will go for the 79. Okay, and the color will be red and yellow. Of course, this will not look in the software, but somehow you need to put it into the your family which you are using in your project. Okay, so or naming, whatever way you can segregate it, but you need to know that. So that's it. Now coming to the types of sprinkler, so this is the color coding of the sprinkler. Now we'll come to the types of sprinklers. So the types of sprinkler, basically we have wet type, dry type, uh, let me note it down. You can also note it down. So wet type sprinkler and dry type sprinkler. Okay, so dry type we use in the places where, like, freezing problems are there, for mostly in the Europe and USA, where the temperature falls below the 0 degree and the water inside the pipe start freezing. So in that case, the complete system, comes out of the order, like it's not operational anymore. So in those cases, what we keep is, we keep the pipe hollow, filled with the nitrogen gas, and the sprinklers are there in the blank, without ready water, and there is a valve outside of that one. From there you can operate it. Once the fire happens, then only it allows water to go, and the water which is kept to be thrown are above the 1 degree temperature. So they make sure that that doesn't get, frozen because of that environment. But in our cases, in the Middle East or India, when where we are working, or other parts of the world, where the freezing phenomena is not happening, there we are using the wet type sprinkler. Okay, so in the wet type, this was the color code. Okay, so we are not going to deal with the dry type, we are going to use with the wet type sprinkler. Okay, then this system, okay, this system is combined with one pump room from where the pressurized water is coming. Then this line, one line from that same pumping station comes out, and there is a PRV station, and then it goes to the alarm check valve, and then it goes to the sprinkler system. This we call it riser. Like it serves like a main header to provide the sprinkler, the water to the sprinkler. Now the two things you have to see here is, first of all, sprinkler system is automatic system, so it does not require any person to activate it. It activates by itself. But like when the fire happens, it automatically starts. Second thing, fire sprinkler system is not designed to suppress the fire. Like suppress the fire. It's designed, but it's not meant to eliminate the fire completely by itself. Okay, so this fire sprinkler system, it is designed to control the fire so that the fireman can come and they can start firefighting before it spreads to the other zone. So the main purpose of the fire sprinkler system is to contain the fire, not to eliminate it. It's not that powerful that it can completely, you know, uh, suppress the fire of that zone. Okay, so it will only make a zone, like that's why it is divided into a zone. Okay, and in a particular zone we call it fire zoning. So fire zoning system means the building, when the persons are designing, they will design in such a way, like for example, suppose this is a building, so they will divide into the zones. Okay, so like this. So of course every floor has to be a separate zone. Also on the each floor there should be a zone, and these all zones should be separated by the fire rated wall. It means any fire shall not go from here to here if it occurs here. Okay, so this we call it zone. So now you can note it down, every zone. Okay, every zone, you have to decide in the light hazard system, it cannot be more than 4831 meter square. Okay, this is the maximum limit. So you can make a zone of 4831 meter square. Okay, this is in the light hazard condition and ordinary also. Okay, but in the extra you can go for the same, it will reduce to 3716 meter square. Okay, so you cannot have a zone more than 3716 meter square in a extra hazard, which is like very like chemical or plastic processing unit kind of places. So don't worry about that one. The project we are mostly dealing are residential and commercials, which comes into the light and ordinary hazard classes. Those classes we can go for the one zone fire zone will up to 4831 meter square. Okay, so now if our building has, now I'll ask the question, if my building has, let's say, one floor. Okay, so let me test your knowledge. So suppose I have three floors. Okay, like this. Okay, let me delete this one. So this floor, let's say I have usable area of each floor. Let's say I have usable area of not each floor, on the top floor, let's say I have area of 4500 square meter. Okay, now on the second floor I have a area of let's say 5600 square meter. Okay, and on the ground floor also 5600 square meter. How many fire zones should come? Tell me, who can answer it quickly? No one? Anis? Anish,
Hello.
yeah, tell me.
Yeah. Can you please ask once this? Hello.
The top roof one here,
Okay.
like the top floor, it has the area of 4,500 square meter.
Okay.
The floor below it has the area of 5,600 square meter, and
Okay.
the floor below it also have the 5,600 square meter. So how many fire zones should come in this building for a sprinkler system?
I'm not sure.
Why you are not sure?
Last time the class I didn't hear the class. Okay.
Resume, it is.
Yeah, it is. If you are divide, suppose if you making the total of this three floor
Hmm.
and divide by 4,381 square meter,
Hmm.
because we need each ordinary hazard, we need minimum not more than 4,831, right?
Yes.
So if you divide, then it is become a 3.2, means we need four zone.
How for zone? Five zones,
Or
no?
no, no. If we
So
divide, no, no. If you
no, no,
divide
no.
it, suppose
Listen once again.
okay,
There is a requirement of each floor has to be a separate zone, regardless of the
hmm,
area. If it is
okay,
a separate floor, it must be a zone. There is
okay.
no question. Even 100 square meter, if it is in another pole, that will become a separate zone. You cannot
Yes,
combine with the floor
okay,
below
okay,
it.
okay,
Okay?
okay. That means it is a five. Yes,
Yes, correct.
Uh,
Okay.
yes, yes,
So
yes,
totally five zones. It means suppose here it is the area of this floor is not more than 4,831 meter square, means we can convert this as a one zone. Okay.
yes,
And then here we can convert this into two zone. Right.
yes, yes.
So total five zones, right? Now even if the top floor this area is of 100 meter square, you cannot combine with this one, and suppose this is 4,500 square meter, so still we have 300 or so left out. So we will think logically that we can combine this zone with this, but no, each floor has to be on the separate zone. Okay. So now why explaining you these things, because each fire zone has to be served by a zone control valve. That is very important. Okay, zone control valve. So the fire riser which comes from the fire room, it goes with this direction. Okay, and now these two items I will explain you later. So it serves to one fire zone. Okay, so you see here, every level it is one zone control valve is coming. Okay, and it is then, like the first riser is there, from riser one pipe is coming out, and then immediately when the pipe is coming out, you have to provide a fire zone control valve. Okay, zone control valve, we call it ZCB. So ZCB must be provided immediately after taking the tap from the main riser. Okay, and then after you can connect with the sprinkler. Correct. Now ZCB I'll come back again, but before that, so here let's say one zone is there. Okay, and in the ordinary hazard we are normally using one sprinkler can cover 12 meter square. Okay, so can someone tell me in one fire zone how many maximum sprinkler I can install? Tell me, calculate it quickly. Anis, you no need to refer the previous lectures. I'm just completely telling you today. So I told you one zone has to be 4,831 meter square, right? Let's say that is the area of that zone. Then one sprinkler can cover 12 meter square. So how many sprinkler I can install in on one zone?
403.
How?
4831 divided by 12 square meter.
Correct. So you can divide the area by the one sprinkler coverage area, and then you can get it. Now the this we can decide like a basic calculation we can do it, but in actual what happens, in actual some overlapping also happens. So when we are arranging the sprinklers in a line, okay, so let's say here we are putting one sprinkler and then after that this one, so there is a gap created, okay, in between. So one sprinkler should cover 12 meter square, but in between this dead zone should not occur. Okay, so what we do is we arrange it in such a way that these zones are like minimized. Okay, so for that to cover in 12 meter square, normally 4 by 3 arrangement is the best arrangement. Okay, 4 by 3 means you can arrange this distance between the sprinkler to sprinkler 4 meter this side and then 3 meter this side, or if 3 meter this side then 4 meter this side. Okay, so 4 by 3 meter arrangement is like the most suitable arrangement. 90% of the places we are using it, but if you find a way to do it even better, then you can do it. Okay, so it's not like a hard and fast rule, but given that, now you can note it down again. Okay, so the distance between the two sprinkler cannot be more than 4.5 meter in any condition. Okay, the situation number one is the distance between the two sprinkler cannot be more than 4.5 meter in any condition. Okay, then the distance between the wall and the sprinkler cannot be less than 100 mm. Okay, then the distance between two sprinkler cannot be more than 2.25 meter or the half of the two distances. Like if it is 3 by 3, then it cannot be more than 1.5, and if it is 4 by 4 means it cannot be more than 2. Okay, and in max condition, so half means 4.5. If you divide, I remember I told you that maximum distance you can go is 4.5, so it means you can do that half of that one, so 2.25 meter. Okay, so you cannot have in any situation the distance between the two sprinkler more than 2.25. Okay, and then the nearest, like you cannot completely stack your sprinkler with the wall, but you have to have a distance of 1 point, sorry, 100 mm, and then the maximum distance from the wall. Okay, suppose there is a end wall and after that there is no sprinkler, that cannot be more than 1.8 meter away. Okay, so remember, are you guys writing these all things? Because you cannot remember it, it's a little bit tricky. Okay, so the minimum distance from the wall to the sprinkler should be not less than 100 mm. Sorry, you cannot go beyond that. Okay, like less than 100 you cannot go. Far you can keep. How far you can keep maximum? 1.8 meter. So you cannot go more than 1.8 meter away from the wall. Okay. Then the sprinkler between the distance between the two sprinkler, you cannot keep it more than 4.5 meter. Okay, or in best case we are using 4 meter, even 0.5 meter we are reducing so that we can cover these dead end areas. Okay, that uncover areas. So the best practice is we are keeping the distances between that the gaps is the half of the sprinklers between the each, and the sprinkler to sprinkler distance we are keeping 4 meter. Okay, so is it clear? Now once again I'm repeating it. The wall to sprinkler distance 100, not more than not less than 100 mm. The wall to sprinkler maximum distance cannot be more than 1.8 meter. Okay, sprinkler to sprinkler distance cannot be more than 4.5 meter. Okay, and then yeah, that's it, right? You got it. Now another thing, you cannot have same thing like minimum distance between the two sprinkler also cannot be more than 1.8 meter. Okay, same like, so the wall distance what you are covering, same way you cannot have the sprinkler too close also, you cannot have that. So you will think that anyway it's good to cover, like it will cover more area, that also you cannot do because it obstructs the spray pattern of the sprinklers. Okay, so that also you have to add it. Okay, now I'll go to the principle how it works. So basically what happens, if fire is happening, and now these calculations once again how they calculate it, one zone, yeah, sorry, one fire at one place. Okay, one fire at one place. So now here you can see that these all zone control valves, it is meant not to operate at the same time, but if the fire is happening, then in that fire case the sprinkler will break. Okay, how the sprinkler will break? You remember, when the fire will happen, the temperature will go, and the temperature once reach to that 68 degree or 79 degree, depending on the type of sprinkler, it will break the bulb, and after breaking the bulb it will start spraying the water. Okay, so once the water will spray, then automatically this system will start, like the pressure will start dropping automatically. This system, the panel will understand that there is a loss of water pressure in the water, so it will start the pump. First it will start the jockey pump. Jockey pump will run to maintain the pressure. If the so many sprinklers are operated at the same time, then it means more water demand is there, and then jockey pump will fail to provide the required flow. In that case, electrical pump will start. Then it will start giving the complete flow. If the electrical pump also shuts down, like for whatever reason, maybe the wire is burnt or whatever way, if the electricity power is gone, the electrical pump will not work. In that case, diesel pump will start, and that will start serving. Okay, then how this all system works, I already explained you, like how this things works in combination. But you have to remember from here that then it works in and it provides the water. So we assume that one zone control valve will operate in one scenario. Okay, now that will serve the one zone control. One zone will be served by, like it will be served in the area of 4831 square meter, right? Now coming to the zone control valve. So zone control valve is nothing but the combination of butterfly valve, then flow switch, pressure gauge, and then there is a drain point here. So in case of maintenance, what we do is we drain this pipe out, the water, and then it goes to the same. You remember yesterday I told you that there should be a drain pipe which should not be less than 3 inches, which is 80 mm here. So that one, it goes and connects there, so we can drain it out at any time, and then it goes back. Now, so installation point of view, what is important for you? The pipe, when you are taking from the zone control, if anytime if you want to drain that water of the sprinkler system line, you always need to model that like this. If the pipe is going in up and up and up, then whenever you need to drain this water, it can come back like this, like this, and like this. And from here, suppose like this, if you have the drain valve here, from here it can go like this, and then you can connect it here. But if you will do this piping in such a way that, suppose I'm doing it like this, the piping I'm making from here to here, and then I'm going down, and then I'm going up, and then I'm going down, and if you try to do like this, then what will happen? The water cannot come here and drain it. So the water here will not go up by itself, like by gravity. So you cannot drain this. It will trap here. So in that case, here also you have to give the drain point. So what is the purpose? To avoid the drain points to give everywhere, because we have to connect the flexible hose, and then we have to take it to the nearest flow drain. So better is to do the piping in such a way that your drain can happen smoothly. Okay. Now the another thing is, when we make the sprinkler pipe, so let's say if from the zone control valve one pipe is coming like this. Okay, and then this is like this. Okay, so the pipe, which the branch pipe, this we call it branch pipe, and this is, let's say, main pipe. Okay, so when the connection is happening with this main pipe, then I will draw a section here. The connection should be in such a way that it should be, let's say, this is a sprinkler main pipe. Okay, then the stem pipe, the branch pipe, you take it like this up, and then again you take it like this. So what is the benefit of this? Again, same benefit you will get it. Two benefits you will get. I will explain you. So first benefit, what you will get? First benefit, your drain can occur very easily, right? It can happen like, from here it can come to this, and then it can go back. Also, when you connect directly from here, then also drain can happen, but the scaling forms happens. When since this water is dumped there for a long time, the scaling, like the debris are tends to collected in this bottom portion, which can obstruct the flow. So this is always advised, if you can take it from the top, the debris collects at the bottom, so that the chances of choke up of this pipe is less. So that's why we keep it on the top. There is no rule that which says that you cannot connect like this, but this is the best practice. Okay. Now, when you are installing the sprinklers, so basically on the application side we have three kinds of sprinkler. One is pendant, upright, and then sidewall. Okay, so in the pendant there are two types of sprinklers. One is normal pendant sprinkler, and one comes with the recessed type. Okay, so recessed type, what it happens, it comes with the ceiling. We can hide that into the ceiling. So basically what happens, suppose this is how you are connecting and this is your ceiling level. So the arrangement of this sprinkler is such a way that it does not pop out from the outside of this, so it fits like this, and when the fire happens it comes out, and in that then it start spraying the water. But if it is a pendant, it normally it happens like this, so it is always outside, like it is always visible. The aesthetically this doesn't look good, that's why they use the recessed type. So it comes with a cap and it comes fits into the this one, the what do you call, the ceiling. So I'll show you the Google image. Let's see. Okay, sprinkler recessed. uh, Pendant sprinkler types. You see this? So this is the concealed one. Okay, and this is the normal one. So this is, you see, and this is, and semi recessed also comes. Semi recessed means half inside half outside, but normally we use that the two types. So this is completely pendant. Okay, complete pendant, and this is the complete recessed. Where it gone? Where is it? This kind. Okay, this is completely concealed. So this actually flush out with the your ceiling. After the installation, if you see, it will match with the color of the ceiling, and it will not look like this, out of the ceiling. This one you see here. So this just flush out with the spring, your ceiling. But in the case of operation, it pops out below and then it start spraying the water. Okay, so that is the difference. Now the pendant, sorry, the upright, same like pendant, but it goes like up way. So in the places where there is no ceiling, we can use the upright sprinkler. Okay, and the places where the ceiling is available, you need to use the this recessed or pendant sprinkler. Okay, the pendant type, but recessed or semi recessed or what, normal pendant. Okay, so now this you understand the criteria to install this in the, from the soffit. So for example, so ceiling anyway you will keep it a pendant, but suppose if there is no ceiling, then you have to install this within the 25 and 300 distance. Means the distance from the soffit of your sprinkler should not be less than 25 Okay, so here to here the distance between the soffit to your sprinkler must be 25 away. Okay, it cannot be closer, like you cannot touch it directly with the roof. Okay, your slab. So it has to be 25 away. Also you cannot go too far, which is 300 Okay, so your sprinkler ideal place is to install into the 25 away, but within 300 away, like the range from the soffit. Okay, the distance between the soffit. Okay, so now we learn a lot of things. So based on things, you can check lot of things what your modelers are doing wrong in the model, right? So you can check it this way. If suppose someone is pendant, they're installing, and the distance between the pendant to your sprinkler is 500 it means this is the wrong modeling. Okay, so that we have to check. That's why this technical knowledge is important. Okay, so you have the information, and based on that, suppose if you'll do that way, you'll put the label of this pipe also below, and everything will go wrong, right? And there is a question like, can we put the pendant type, not upright type, in the non-ceiling area? Yes, we can do it, as long as you can get it done within the 300 space. Okay, but to use a pendant within the 300 space and then connecting with the header pipe, it is too difficult to install. That's why we keep it upright, so you can keep it this whatever level you want, and then this you can show it upright way, and then you can install it. So it is easy to install. That's why in the non-ceiling area we use the upright sprinkler, and in the ceiling area we use the pendant sprinklers. Clear? Now coming back to the zone control valve. So zone control valve is consist of butterfly valve, and then the pressure gauge, and then flow switch, and then this one, the drain. Okay, this butterfly and this flow switch. So zone control valve is not a separate one valve, it is a combination of these all valves. Okay, and this has to be installed on an accessible location. Okay, so first criteria for the zone control valve is it must be on an accessible location. Okay, so anywhere where the persons can access it and maintain it. Okay, then it has to be, you know, indicated like below one nameplate should be there that this is a zone control valve and all. Okay, that is requirement. Then this zone control valve and this flow switch, this all arrangement has to happen within the 600 mm. Okay, so you cannot have the flow butterfly valve here and your flow switch somewhere here 1 meter away. Okay, or pressure gauge 2 meter away, you cannot have that. These all installation you must have within the 600 mm of space, all these arrangements. Okay, and the combination of these all arrangements we call it zone control valve. And that zone control valve, you cannot hang it somewhere where in the riser, somewhere where the people cannot reach. It has to be on the accessible location. So now what are the things you can check for your model visually? If you are going to review a model, now whenever you will see the model, you can look the model from the very different perspective. You understand? Before you were looking in the BIM model and it was looking clean and very, you know, you was happy, right? But now when you will see the model, you will see from this perspective. So for example, yesterday I told you wetrizer system. So when you will go and observe this one, you will very quickly it will come to your mind. Okay, this must be 25 mm. If he is using 50 mm, it's wrong. If using here 40 mm pipe, it's wrong. You know, but because you know that it should be minimum 65. This must be 25. Okay, then this pipe must be covering the 30-meter away. It cannot be more than 6 meter away from the staircase. The distance should be from the door to the, you know, this fire hose cabinet. Same way sprinkler. Okay, so minimum distance to the wall, it cannot be more than 100 mm. It cannot be away 1.8 meter away from there. The distance between the two sprinkler cannot be less than 1.8, and it cannot be more than 4.5, right? So these all things you can see visually. If it looks like a little bit weird, you can check it and you can verify the system is done or not correctly. Now then coming back to the, you are following, and they have installed so many, like, you know, the let's say 700 sprinkler in a line. So you can get a downlight only by using one zone control valve. They are using, maybe they are covering more than 4831 meter square of area. It means that is wrong, you know, code wise. So that also you can correct it. Here we need the two zones, two fire zone control valve. It cannot be handled by one zone control valve. Okay, then zone control valve must be installed on a accessible location. That also you can check it. Then this zone control valve assembly can be within only 600 mm distance, and then it must be connected with the riser, and also drain point must be provided. Okay, this drain line. Then while considering the drain point, you can see that your pipe should not go up and down, up and down, up and down, right? So that also you can see. Then you will go to the installation of that. In the elevation wise, though, your sprinkler must be in the 25 meter away, 25 mm away, or not more than 300 away from the soffit. Within that range your sprinkler must be there. Okay, then suppose you are providing a sprinkler, and in between any duct or any item which is coming, which is bigger than 1200 mm wide, then you must be providing a sprinkler below this item also. Okay, even if the above you have provided, the below also you need to come and cover this area. Okay, so that requirement is also there. Then you are coming like this, you know, and then at the bottom of the riser, then an alarm check valve must be there. Okay, now one more thing you need to care here. In this line also one breaching inlet. You remember yesterday I told you breaching inlet, which is connected from the truck, which is coming from the municipality, like, you know, fire department, so they can connect. So same like wet riser system we are giving, here also we are giving one connection to the system directly from the truck, okay, so that in the case of failure of this system, they can directly supply the water to the system from the truck, okay. So it's like a backup system. So this connection has to happen after the alarm check valve, okay. And then if you are taking a wet riser system connection, okay, from the same line, the wet riser connection has to happen before the alarm check valve, okay. So these two things are critical, you need to understand this, okay. So whenever you will connect the take the out, like the branch for the wet riser system, it must be connected before the alarm check valve. You cannot connect it after the alarm check valve, okay. Now what is the use of alarm check valve? So first of all, it is a check valve, so it allows water to go from the one side to another side. So from this side it is going, this side it will allow, but it will prevent to come the water from the back side to the this side, like it will stop the flow from the back side if it's coming. So you remember, it's a pressurized system, so always pressurized, and then the water is filled into the system. So this will hold this water into this in the pressurized condition, okay. So once this is going and the required pressure is achieved, it will stop, and this will not allow it to go back. Otherwise, this is a riser, this is going to a very high rising height, so water will tend to come backwards, and then it will go back, and the motor is not operating in that condition, it will start rotating, and it will go back to the tank, like and it will start rotating these pumps in a opposite direction. So to prevent these all phenomenon to happen, we keep it one check valve. Now the name is alarm check valve because it starts alarming once this system is activated. So this is the automatic system. So when it starts and the water flows from this direction to this direction, it automatically starts playing the sound. Okay, so there is an alarm in this one. Then that starts giving the alarm to the people. They come to know that this fire sprinkler is working now. It means somewhere fire is there and the system is active. So then they start evacuating, like they become active towards the cause. So that is the work of alarm check valve. Another thing is, there is a two pressure gauge in this alarm check valve. One checks the pressure of the front side, and one check the back side, okay. So differential also it can measure. So for example, here suppose there is a pressure, okay, if it is less than required pressure, then this will give you signal that this line has the less pressure, okay. And also, if this side of this water is, there is no water in this one, then also it can give you the signal. So we can know that both side of the pressures are there or not, the required or whatever we want, okay. Also, there is here a surge protection. So suppose sudden in the because of the up and down, or sudden surge in the pressure, of course that also it can handle here for the false alarm, like in false condition it will not allow the system to break, okay. So these all things it does, okay, one alarm check valve. That's why in the each riser we keep one alarm check valve, okay. So now when we see that this system, so first it is made with the tapped with the pressure PRV system, we call it pressure release valve, okay. So this is assembly of valve again, the IV, and then in between the pressure reducing valve, okay. So and this also comes with the one working, one standby. So if you are doing maintenance, this one, this will be working, and this will, if you are maintaining, this will be working, okay. So this pressure reducing valve we are using in all these lines. Why? Because these all lines, you remember, these all lines require the different pressures. So what I told you, so suppose this line is on at the remotest location, it requires the 1 bar pressure at the sprinkler. So to make the 1 bar there at the remotest sprinkler, you have to have a lot of pressure in this line itself, right? So in order to achieve this one, maybe this pressure line is going more than, suppose for this you need a 12 meter square, sorry, 12 bar pressure, but in this line you need only 6.9 bar, right? And maybe to reach to another one maybe 8.10 bar, right? And this is this you need 12 bar. So there is a 2 bar difference, so that is managed by this pressure reducing valves, okay. So we call it PRV station also, okay, PRV stations. So that's why we use the PRV station in these lines, okay. Then this is all. Then there is a specialist, okay. Alarm check valve, that's done. Batching inlet is done. So this is all the sprinkler system, okay. So now when we'll see the fire model, First of all, you need to go and see the fire room, like what do you call this fire pump room. Okay, then you will see these all elements are correct or not. Then you will go to the wet riser system. From start to end you can measure, see it in one look, and you can know that whether, and by checking even only one floor you can know that what kind of modeler is that. Is he aware of the things or he is not aware of the things? If you'll find multiple problems in only in one first floor model itself, you can become very conscious that there is a high chance of that 70 floor building there is a lot of mess in the model, technically, because these modelers whoever is doing is not aware of the rules and installation details. That's why they are doing so many mistakes. If one floor you will check and you will find everything is fine, consistent, then you can make sure that okay, there is a chance of less error in this model because this person who has done this modeling is well aware of the system. He knows the rules and regulation, at least of the modeling standards. So that's why you need to know the system technically, from technical point of view, so that you can monitor your people whether they are doing it the good job or not. Okay. Now, based on this, I expect you to make the checklist. So you guys have noted down, right? Whatever I told. Excuse me. Okay, guys. So can you guys make the checklist based on these all three things what I explained?
Sure, sure.
Yeah. Please make it, and then by next session I will see that who has done it. So
Okay, but I have one question. This
hmm.
zone control bar, there is a maximum GPM. How much we can take? Is there any calculation like that?
No, no. GPM calculation is a designer's job. That's why I'm not going to cover here deeply, because there's a design density. Okay, design
Mm-hmm.
density. Okay, so based on that, the design, like so let's say this depends on which class of building is this. Okay, so why that is not important for us, because so they choose that they need 1.5 like 1500 square feet of area to covered by the sprinkler. Okay, so based on that, if they have the k factor 5.6, they will multiply it and they will get the flow rate of this area. Okay, so if
Okay.
they can achieve that area of the remotest location of the building, that much flow rate they require. Okay, now
Mm-hmm.
this changes based on the building type and the application of that area, what kind of area is that. Okay, now this does not affect us as a modeler. This affects as a
Mm-hmm.
designer, the person who is designing this complete system. For them it affects, but for us it doesn't affect. Okay, we need to know the
Okay.
installation detail and modeling details. So that's why if we'll start teaching those all things, then we'll go in very deep, like it will take a lot of time. So that's why I told
Mm-hmm.
you
Okay.
that we'll learn only the things what matters in our scope. Okay.
Okay. Okay. Thank you.
Okay. Okay, guys, anyone has any other doubt? So this fire system done. Okay, we'll see the specialist services, like this deluge system and this what do you call FM200 also quickly in the upcoming sessions. We'll go through those. Are not major, like I told you now that 80% of the time your modelers will be doing these jobs, only these three jobs. What? The plant room, the wet riser system, and the sprinkler system, and this is all that rule are. Okay, then after that, small rooms, so small gas cylinders are there and the sprinklers are there for that gas suppression system. Those are small, like I will show you on detail, but anyway, you cover the most part which is coming again and again. Okay, then we'll go for the another session, like another system in coming weeks, the HVAC electrical, like that. Then after that we'll come to the civil part also, architecture, structure, what are the things we need to care into those areas. Then we will have the perfectly, the technically sound, kind of a skill. Then we'll go back and see our models. What is the error? Then I'll ask you, what is the error? You take it your model where you are working, and then you try to find out, look it from the different perspective, like engineer, not like a modeler or reviewer. Okay, so look like a, from that perspective, you will see that same model very differently, and then you can very quickly check and correct it, or one project if you do like that, Then upcoming project you can instruct your modelers a lot before then they start the project, so they will make a lot less error.